Hello everyone, welcome to the class. This is Genesis Training and I'm your trainer Mohan Raj. So we have seen so far ratio, proportion, variation concept. Full 5 videos we have finished, and we have also finished questions on number theory as well as speed maths. Now we have another interesting topic called equations. So in the equations, the first video is all about linear equations. Let's see what is linear equation, what are the types of questions we get here. So first we are going to understand what is simple linear equation. An equation in which each variable occurs only in its first power and not in higher power is called linear equation. And the linear equation with a variable x and y represent a straight line in the xy plane. That is why the name linear equation. Degree of a linear equation is nothing but power of the highest term, highest power of the given terms in the equation, that is always 1, because x power is always 1 and y power is also going to be always 1 in this kind of equations. So types of linear equations. A linear equation with one variable, that means we have to solve one equation with one variable, means we need one equation, and two linear equations are there, means we need to have two equations, two variables are there, means, and if we have three variables we need to think about three equations. Okay, so and there is some conditions here. If we consider ax plus by plus c equal to 0 as the general form of a linear equation, then we have abc as a real constant and x and y are variables. If a is equal to 0, x cannot be 0, x will have infinite values. If a is a constant and that is equal to 0, then we get an equation by plus c equal to 0, which means y is equal to minus c by b is the equation which is actually parallel to x-axis. That means y is equal to constant is always a parallel to x-axis. Similarly, if b is equal to 0, in such case our equation becomes x is equal to minus c by a, is x is a constant which is a parallel to, which is an equation line parallel to y-axis. So types of linear equations are done, and we are going to now solve them. How to solve them? If there are two linear equations with two variables x and y in this general format, a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. These conditions are very important now. Case 1, if a1 by a2 is equal to b1 by b2, that is also equal to c1 by c2, that is nothing but a same equation. Both the equation represent same line. One line has infinite points, that means every point on the line becomes a solution. That means we have infinite solution. So there is no unique solution. Second case, if a1 by a2 is equal to b1 by b2 but not equal to c1 by c2, that forms a pair of parallel lines and they will never have a common point of intersection. That means there is no solution for such questions. And the last one, if a1 by a2 is not equal to b1 by b2, then the equations represent two intersecting lines with a common point of intersection. That will give a unique solution. That means very important condition, to solve an equation they should intersect. To intersect, this is the case we are going to check. a1 by a2 is equal to b1 by b2. So every question before solving, check this condition so that you don't have to waste time in solving such questions. Let's see first question here. First question says solve for a and b. So two variables, we have two equations. 2a plus 5b equal to 11 and then 3a plus 4b equal to 6. There are two ways to solve this. One is by substitution. A can be replaced by, in the first equation, as 11 minus 5b by 2, and that can be substituted in this equation and we can solve that. Or else we can go for the rule of simultaneous linear equations, where we can eliminate one of the variable by multiplying their coefficients mutually to the other equation. For example, coefficient of this, I am going to eliminate a now. Coefficient of this is 2, so we will be multiplying this equation by 2. And coefficient of this a is 3, so I will multiply this by 3, and I am going to subtract so that a will be cancelled. So if they have same sign, we subtract. If they have one different sign, we are going to add them. Okay, now both are positive, so I am going to subtract. So you don't have to worry about a, because 3 into 2a is 6a, 2 into 3a is 6a, they will cancel. 3 into 5 is 15b minus 2 into 4 is 8b, which is equal to 33 minus 12. So what I can see is 7b is equal to 21. So b is equal to 3. Substitute this value in this equation. So 11 minus 5 into 3 divided by 2. So what I get is 11 minus 15 by 2, which is minus 4 by 2 minus 2. So answer for this question is 2 minus 2 comma 3. A is minus 2, B is 3. So that is the solution. It's a very simple question. Let's go to the next one. So here it is a word problem. A, B and C have a total of 2800 rupees. There are 3 unknowns. So if you want to solve all of the 3, we need to have 3 equations. But what they're asking, let's see. 4 times the amount with A is equal to thrice the amount with the other 2. Who are the other 2? B and C. So we have 2 equations. And what they're asking is only to find A. So I can solve for A alone in this question, but I cannot talk about B and C because we have only 2 equations, right? So I can replace this B plus C by 4 by 3A using the second equation in the first equation. What we get is A plus 4 by 3A is equal to 2800 rupees. So when I solve this, I get 7A is equal to 3 into 2800, and we know easily we can divide by 7 400s. So the value of A is actually 1200. What is the value of B and C? We cannot solve this because the information is not clear about them. We need one more equation to solve B and C. Let's go to third question. There are 5 consecutive integers. So let us take one integer as x. So other integers are going to be consecutive. So it is simply x plus 1, x plus 2, x plus 3 and x plus 4. The question here is the thrice the middle integer, which is x plus 2, thrice that is equal to sum of the greatest and least integer exceeding by 12. That means 12 plus sum of the greatest integer x plus 4 plus the least integer x. So we have only one unknown, one equation is enough to solve them. First let's find x, then we can find the greatest integer, which is x plus 4. So I can write it as 3x plus 6 equal to 12 plus 4 16 plus we have 2x. So if I am not wrong. So now what happens is x will come to this side, it will become 3x minus 2x is x, and 6 goes to the right side as minus 6. So we get the answer as 10. What is the question? Find the greatest integer. The greatest integer is x plus 4, which is 14. Let's go to the next question. Mohan purchased 2 mangoes and 3 apples for the cost of 29 rupees. So now we need to establish the variable, as it's a word problem. We need to establish the variable. Let us assume cost of 1 mango is m, cost of 1 apple is a. So he purchased 2 mangoes and 3 apples for 29 rupees. If the cost of a mango is twice its original price, initially we took it as m, now it is going to be 2m, and then the cost of 3 mangoes will be 3 into 2m, which is directly written as 6m. So I am taking it as 3 into 2m, directly I am writing it as 6m, avoiding one more step. And then cost of 5 apples is equal to 67 rupees. What is the question? They are asking us to find the cost of a mango. That means we don't have to waste our time in solving for apple. Let us eliminate apple. How will you eliminate apple? Coefficient of apple here is 5. I am going to multiply this equation by 5. And coefficient of this apple is 3. I am going to multiply this entire equation by 3. And we are subtracting them. So what we get is 5 into 2, 10m. Minus 3 into 6, 18m. Which is equal to 29 into 5. So we know 20 into 5 is 100. 9 into 5 is 45, so it's 145, minus 3 into 60 is 180, 3 sevens are 21, so what we get is 191. So when we solve this, I get minus 8m is equal to minus 56. So m is equal to 56 by 8, which is simply 7. So original cost of a mango is 7 rupees. Let's go to the next question. If both the numerator as well as the denominator of a fraction are increased by 1, it becomes 5 plus 7. If both are decreased by 3, it becomes 2 by 3. Find the fraction. Let us assume the fraction as a by b. First condition says if both are increased by 1, we get 5 by 7. If both are decreased by 3, we get 2 by 3. So what is the value of a and b? So obviously we can cross multiply and answer them. Or is there any better method? That's my question now. This is easy. It's but we need to solve it in a better way. So what I can say is A B's ratio was 5:7 when you add 1, and when you subtract 3 it becomes 2:3. Now we need to understand from +1 to -3 how much I have to remove. Actually I have to remove 4. While removing 4, what happened to this is 5 is reduced by 2 and then 7 is reduced to 3. So can I make it even better? So can I rearrange this ratio by multiplying by 2? Because there's no linearity here. So both are decreased by same number, but ratio wise they are not decreased by same. So to make it that easy, so I am going to multiply this as 2, so it becomes 4 and 6. Now you can see 5 is reduced by 1 and 7 is reduced by 1. But actually we are reducing -4. From the ratio concept I can say one part is actually equal to 4. So one part is 4 means what is the original number? The original number was, we don't know, but +1. After adding 1 it has become 5 and 7. So I can say 5 part is 20 and 7 part is 28. It was after adding 1. So before adding 1 it will become 19 and then 27. So what is the ratio? The ratio will be 19, the first fraction is 19 by 27. So you can even check it, when you add 1 to that it will become 20 by 28. Okay, when you remove 3 from that, so it become 16 by 24, which is actually 2 by 3. So the answer is correct. So this is the approach. If you are not understanding, no issues, you can do the cross multiplication and do the elimination method by simultaneous linear equations. Let's have one last question in this equation concept. A test series consists of 50 questions. Each correct answer fetches 1 mark. For each wrong answer we get half marks deducted. So a candidate who wrote the test attempted all the questions, he scored 41 marks. Find the number of questions he attempted correctly answered. Let us assume C as a correctly answered and W as a wrong answer. Totally how many questions? It is 50 questions. In the 50 questions he correctly answered C number of questions, wrong questions like this. Now each correct answer fetches 1 mark. So that means when I attend one correct answer I'll get 1 mark. So C number of questions I attend correctly, I'll get +1. And each wrong answer I'm going to lose half mark, minus 1 by 2 W, and the total marks he got is 41. So I can simply solve this by subtracting. So what I get here is this C will cancel. I end up with 3 by 2 W is equal to 50 minus 41, 9. So W is equal to 9 into 2 by 3, which is equal to 6. That means he attempted wrong question 6. That means the right questions, correct questions are going to be 50 minus 6, which is simply 44. This is one way to solve. Is there any other logic? Assume all of them have been correctly answered. If all have been correctly answered, I would have got 50 marks, right? But one correct answer to one wrong answer, how much is the difference? So let's see. So the question was, if it is completely correctly answered, what happens? So if all are right, we would have got 50 marks. But because of our mistakes, we have got lesser marks, right? So let's see. 50 marks I would have got if I had got all the right answers. But I am getting only 44. So 41. What is the difference? 9 mark. And let us understand, for every right question to wrong question, how much is the difference. So I get 1 mark and I lose half mark, right? That means I lose 1 mark as well as half mark because it is wrong. So I need to understand I lose 3 by 2 marks, right? So in this difference, for one question the difference is 3 by 2. So how many questions I have got? So for one question the difference is 3 by 2. I lost 9 mark. So how many questions I got it right is got it wrong is 9 by 3 by 2, which is 6 questions wrong. That is also one way to solve. So if you are not understanding the shortcut, no problem, you can go for the equation method. So that is the end of this video. So we can again connect with another equation method in another equation concept in the linear equations, that is problems on edges, how to solve questions with equations. We can solve that in the next video. So till that we can practice more and more questions on equations. So we can meet again in the next video. Thank you for your time.